So with so many possible combinations of the predictor attributes, right, you may still have a lot of data, and yet there may be very few rows or very few cases that satisfy the condition for each of these cells. Okay, and you may end up with many empty cells, right? So if it's an empty cell, what does that mean? That means for a certain combination of your predictor attributes, our data set has no data, right? In fact, that is the case in the airline data that we just examined, right? Uh, you have 18,000, more than 18,000 combinations of the predictor attributes, and we have only 2,000 rows of data. So clearly, many combinations are not even represented in our data set. So if they turn up, how do we make a prediction for them, right? So it is for this reason that exact Bayes may not work in these conditions, and we need an alternative. And that is where we talk about naive Bayes, right? So what we are looking for is the probability of status being delay given our combination of predictor attributes. Let's say the day of the week is Monday, departure time is 3 p.m., origin is this airport, destination is that airport, the carrier is United Airlines, and the weather is good, right? So all of these are the predictor attributes. And then we are saying, given the values of these predictor attributes, what is the probability of delay, right? Again, if we had enough data, we could compute this simply by applying exact Bayes. But for good reasons, because of the curse of dimensionality, you just may not have enough data to use exact Bayes to make this prediction. Well, then what do? That's where we apply the Bayes theorem, right? We say, in order to compute this probability of delay given all of these, we can try to compute that using the probability of all of these given delay, which is inverted, just like the Bayes theorem allows us to do, and then compute the probability, right? So what we want to do is probability of status given delay, a given lot of other conditions. We are in trouble because we may not have enough data to do that. Exact Bayes cannot work. Well, we're going to approximate. We're going to generate an approximation for this probability using the Bayes theorem as the basis. Okay, and that is what we call as the naive Bayes approach, meaning it's not a proper application of the Bayes theorem, but it's a naive application which approximates it. Okay, so it computes a good approximation for probability of target equals delay, non-delay, given predictors equal these values. Predictors being, origin airport, destination airport, time of flight, weather, etc., etc.